Hello, class. Advanced Algebra Trig. Here we are in our videos. I hope you're ready to make fun of me tomorrow because I'm not used to this, neither are you, but we're going to do it, and we can. As I said in class, we're going to start watching these videos, watch them at home, and then click on the other link in Edline to complete the 3 to 5 practice problems on the unit. Eventually, when I get more fancy, hopefully over in this area or this area, you'll see my face. But right now, I'm just going to focus on making the videos, and then we'll try to get more fancy later. So our next unit is sort of on organizing things. So our first is on solving. Nope, that one didn't work. Systems of equations with 3 variables. This does not look pretty. Okay, well, I will do better at that. And so we've seen solving systems of equations. Hopefully you remember that from elimination and substitution. We've seen this before, but every time we've done that, we've used 2 variables, like x and y. Now we're going to have 3. So remember that we solved these with substitution and elimination. Or graphing, but since there's x, y, and z, that adds on a totally different axis than the x and y. And so we're not going to go through graphing for these, but hopefully all of you are just so inspired by math after these flipped units that you'll take it some later in college and then you'll see those 3 different axes. Alright, so example, solve for x, y, and z. And my equations, we have 3 variables. If we remember back from before, we had 2 variables, and therefore that gave us 2 equations. Since we have 3 variables, we're going to need 3 equations, because there needs to be the same amount of equations as variables so that we can solve for them all. So, solve for x, y, and z. I have 2x plus 3y. Oh, no, I didn't know that. Thank you. I'll learn that later. Okay, x. Okay. 2x plus 3y plus 2z equals 13. And then 2y, I'm going to line up the y's here, plus z equals 1. And then z, again, lining up the z's, equals 3. Alright, change my color. So, substitution, elimination. Well, I got to find x, y, and z. Look at that, I already found z. Z is already 3, so we know that one. And that makes this problem pretty simple, so we'll do this one first. I have z equals 3, so using substitution, I'm going to plug this in. And once I do that, I'll have 2y plus 3 equals 1. Right? And now look at that. I can solve for y. 2y equals -2. Divide by 2. And y equals -1. Right? Because this simplifies to be a 1 here, so y equals -1. Look at that. We found y. So now the only place I see an x is here, so we're probably going to have to use this first equation. So I'm going to plug in my x up here. I'm going to plug in my y, this z, my z, and my y into this equation, and then I should only be left with x, and we can solve for x. So 2x plus 3. Instead of y, I just found out that y is -1, so I substitute that in. Plus 2 times z, which is 3, equals 13. Alright, look at that. We did what we're supposed to. We found just x. We're left with just x. So simplify here. 2x minus 3 plus 6 equals 13. Combine like terms. 2x plus 3 equals 13. Okay, Mr. Penn. Subtract 3, 2x equals 10, divide by, oh my gosh, and x equals 5. It looks just like a 5. And if you remember back to our other answers, we wrote them in sort of parentheses, and so, or brackets actually, and so that's how we're going to write those. Same way x, y, and z. So I have x is 5, y is -1, and z is 3. Okay? So, basic example. Let's try another one. And this time we might have to use over here in the last one. Uh-oh, not responding. My last slide here, we also talked about elimination. So let's quickly review one of those 2 equation elimination problems. So solve using elimination. 3x minus 2y equals 8. X plus 4y equals -2. Okay, and so you'll remember from elimination that you eliminate or get rid of one of the variables. So like in the last problem, we can't just substitute here because we don't have what something equals to. So what I notice is there's a -2 and a 4 here. If things are going to cancel out, one needs to be negative, one needs to be positive, which is what I have here. So what I'm going to do is make this -2 into a -4, and then these will cancel. Right? So I multiply here to make this into a -4, I multiply by 2, but I've got to do that to the whole equation. So now here I get 6x. This is when I distribute in the 2 here to all 3 of these. So 6x minus 4y equals 16. Okay. And now, as you notice, these should cancel. In order to do that, what operation? I use addition. So I'm adding here x plus 6x, 7x. No drag down. Here 4y minus 4y, well that becomes 0y, and so that's why they cancel. Equals -2 plus 16 is 14. Divide by 7, x equals 2. Plug that back in. Oh, here I see x by itself, so I'm going to plug it into this equation. 2 plus 4y equals -2. So solve for y. 4y is -4. Divide, and y equals -1. Our answer is xy to -1. All right, so with 3 equations, it's similar, but we have to use 3 equations, and so there's sort of an extra step here. So let's try one of these. Okay, so let's say I have x plus y minus 2z equals 7. Negative x plus 4y plus 3z equals 2. And 2x minus 3y plus 2z equals -2. All right, so we just talked about elimination. Hopefully when I was writing those, some things pointed out to you. Here's what I notice. I can eliminate some things right now. I have x and -x right here, so I could eliminate without even multiplying at all. I also has -2z and 2z. Those can eliminate. So really, it's up to you which one you choose. Okay? There's sort of some steps here, and pause and replay if you need to listen to this again. Number 1 is to see if you can cancel anything out by adding. That's what we just said. We could cancel these x's or these -2z's. Then I want to use elimination or substitution to simplify any of those so that I can get rid of one of the variables. The less variables we have, the easier this becomes. Then, once I have a 2-variable system, meaning I canceled out one of the variables, so I canceled out either these z's or these x's in this problem, because there's not really an easy way to do it with the y's. Once I cancel those out, then I should have a 2-system equation. I can solve it like we did in this slide here. with only two different variables. We had x's and y's here. Okay, and then after that, same thing we did down here, plug in the x back in order to get the y or the z values. So I noticed these x's, so what I'm going to do is first, and it might help me to write a little one here, this is what I'm doing first. I'm adding these two together, and so I'm going to put this over here. So x plus negative x cancels those out. Y plus 4y, 5y. Negative 2z plus 3z plus z, and 7 plus 2 equals 9. All right, so here I canceled the x's, but we still need two equations. And I don't want to get rid of these z's next, because if I do that, my other equation is going to have x's and y's, and I don't want that. I want y's and z's. So what I have to do is continue to cancel these x's. Once I canceled one pair of x, I need to cancel the other pair of x as well. And so what else I notice here is I have negative x and 2x. And I can cancel those just like we did in the last equation on the other slide, the last problem on the other slide. I can multiply here by 2. When I do that, this is going to become negative 2x plus 8y plus 6z equals 4. And now look at that. These are going to cancel, right? So now when I add, and again, this is the second thing I did, so it might help here. We did this step first, this step second. I add these together, those cancel. Negative 3 plus 8y gives me 5y. 2z plus 6z gives me 8z. Negative 2 plus 4 gives me 2. And so now I'm left with this two variable system of equations, which I can solve much easier, similar to what we did in the last example. All right, so now hopefully you notice 5y and 5y, look at that. I can cancel those by just multiplying this by a negative 1 or subtracting, really. So actually I'm going to subtract here. I think that's going to be a little bit easier. All right, so let's just subtract. 5y minus 5y, oh, cancels it out. Z minus 8z, negative 7z. 9 minus 2, 7. Oh, divide by negative 7, I get z equals negative 1. Okay, well, z equals negative 1, I can plug it back in here to get y. So 5y plus negative 1 equals 9. Oh, solve for y, add 1. 5y equals 10, divide by 5, y equals 2. Okay, look at that. I'm close. I found y, I found z. Now I got to find x. Doesn't matter where I plug it in, but I see x here positive and by itself, so I'm going to use my first equation here. So I have x, which we don't know, plus y, which is 2, minus 2 times z, which we found was negative 1, equals 7. Okay, so I simplify here. X plus 2 equals 7. Two negatives make this positive. X plus 4 equals 7. And x equals 3. And look at that. Now we can write our answer, which is 3 is x, y is 2, z is negative 1. Okay? Questions on that? If you have any, think about them, write them down, send me an email, ask about them tomorrow. Okay? So again, the goal of this, rewind, pause, go back, try to understand things that you don't understand. We can talk tomorrow or later if you want me to do more or less examples. My goal is not to make the video too long so that you can go and re-watch it. So what you need to do now is go and complete the 3 content practice problems. They are multiple choice answers, so you will choose one of the answers on there and then submit them, and that is only for me to see that you watch the videos. If you get all 3 wrong, well then I know that you just went on there and didn't actually watch the video. So, let's finish this up with my end of the video exercise. This is to let me know tomorrow when you're doing this that you watched the video. I'm going to roll this again, whatever these numbers add up to. You can tell me that tomorrow on your MDP sheet, and then I will give you an extra point on the CPP problems. So ready? All right, there you go. Add that number up. That's a special number. I will see you tomorrow. Good luck.